Hello everyone. So in this video, I'm going to show you how to simplify radical expressions, meaning an expression that involves radical. So these are the examples I'll be working out in this video. So you can go ahead and pause it and then check your answers with mine. So let's get started. Okay, so on this example, we want to simplify what is a square root of 27 over 4. So if the index of the radical is not written, we assume it's a 2. So this is a square root. So by using the property of radicals, we can write this as a square root of 27 over a square root of 4. And now you try to simplify each of these. So square root of 27, we can write that as a square root of 9 times 3. Where one is a perfect square and the other number is a non-perfect square, which is fine. And then on the bottom, square root of 4, well, that simplifies to 2 because 2 times 2 is a 4. And then on top, we still have a square root of 9 times 3. Again, using the properties of radicals, this would be a square root of 9 times square root of 3. So I separate the 2, and on the bottom, I still have a 2. And now square root of 9, well, you ask yourself what number multiply itself twice to give you 9. That would be 3. So it'd be 3 square root of 3 over 2. And we leave it right here. That's our simplified answer. Okay, let's take a look at our next example. So similarly, for this problem, we will simplify each radical expression. So we have a square root of 12. Again, you try to look for a number that multiplies to give you square root of 12 because 12 is not a perfect square. So that would be, if you start writing it down, you'll see that 4 times 3 would give you 12 and 4 is a perfect square. That's why I choose 4 times 3. And then square root of 25, as you know, that's a perfect square. That will simplify to 5. So we just write that down here. And then again, using the properties of radicals, we know the top can be split into square root of 4 times the square root of 3 all over 5. And then square root of 4 will come out as a 2. So we have 2 square root of 3 over 5. And that's completely simplified. So that will be our final answer for this problem. Now let's take a look at the next one. For this one, we will try to do something similar. None of them are perfect squares. So we'll try to rewrite as much as we can and then simplify. So I can hold on to rewriting 12. So I can just keep that as a square root of 12 times. Now 24, that's not a perfect square. So I can rewrite that as, let's go with 12 times 2 because 12 times 2 is 24. And now by using the properties of radicals, we can combine these into a single square root. So we have a 12 and a 12 times 2. So I combine the two expression into a single expression by properties of radicals. So now these guys, you can combine them, you can multiply them. So this will give you a square root of 144 times 2. And now you know that 144 is a perfect square. It's a perfect square of 12. So this can be written as 12 times square root of 2 because the 2 will stay inside. In other words, I can rewrite this by using the properties of radicals as 144 times a square root of 2. And then this will simplify to be 12. That's how we get 12 root 2. So that will be our answer for this problem. Now let's take a look at the next ones we have. Now in this one, we have sum of 2 square roots. Now the way we're going to combine them is by again simplifying and then looking for like radicals. So we're going to simplify each one of them as much as we can. So 75 under the square root, I can rewrite that as a square root of 25 times 3. And I know 25 is a perfect square, that's why I chose that. Plus, now 48, you can write that as a 16 times 3. And again, the reason I chose that because 16 is a perfect square. And now I can simplify them by using the laws of radicals. So this would be 5 a square root of 3 because that didn't simplify, plus now square root of 16, that's 4, and then we still have square root of 3. And now these are called like radicals. They're the same radicals, so we can actually think of the distribution property we studied, think of it as factoring out the same radical and rewrite their coefficients, which is 5 plus 4. And then you can just add them up. So you have a square root of 3 and 5 plus 4, that's 9. In other words, we can just write this as putting the 9 in the front, square root of 3. So that's how we simplify something like this that involves radical. Now let's take a look at our last example. Okay, so for this example, we're doing difference of two square roots. Again, they're not perfect squares, but they have a perfect square inside. So 125, I can rewrite that as a square root of 25 times 5, that's 125. Minus, now square root of 45, I can write that as 9 times 5. And then square root of 25 will come out as a 5 because 5 times 5 is 25, and we still have a square root of 5. Minus, and then 9 will come out as a 3, then you still have a square root of 5 in there. And now by pulling out the like radical, which is 5, you factor out their coefficients, 5 minus 3. And then 5 minus 3 will give us 2, so we have a square root of 5 times 2. And again, we put the 2 on the front of the radical. It's a formal way of writing. So we have 2 square root of 5. So that's how we simplify like radicals. If they didn't have this expression like, then we wouldn't be able to combine. So just keep that in mind as you work through these examples. All right, so that's it for this video. I hope you enjoy learning with me. I'll see you next time.